Hi there, hope you have a fantastic day today. This lesson, I will teach you how to work out the present value. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one, the table is showing the present value for an annuity of $1. So we have interest rates here. So the interest rate is in decimal. So therefore, this means that 0.0095, it means 0.95%. So we would times by 100. So that means we move 1, 2. So that means 0.95%. Okay, just remember that for me. For example, if we have 0.075, so if we times by 100, 1, 2. So this means that 0.75%. And we have N here. N is period. So it could be months, could be years, could be quarters. But in this case, Oscar plans to invest $200 each month. So that means period is month, okay? Let me show you how the table works. So let's say I have N is equal to 70. So this means that I make regular payment of $1 for 70 times, okay? Just remember that. And let's say the interest rate is 0.008. So that is 0.8%, okay? So this means that the present value is, so we start from this interest rate here, and then N is 70. So we just go across here, and we go down. So this means that this intersection here, this point here is the future value for N is equal to 70 and R is equal to 0.008 or 0.8% if you like. So let me just write this down. So the present value PV is equal to 53.4396. This means that instead of investing by regular contributions of $1 for next 70 months, I can also deposit $53.44 and leave it grow for 70 months. So at the end of 70 months, so let me just write this is investment type A and an investment type B. So this means that at the end of 70 months, so the future value of investment type A is exactly the same as the future value of investment type B. So please keep that in mind. And please note that investment type A, because I make a regular contribution of $1 for the next 70 months, so therefore I invest altogether is $70. So whereas B, I just invest amount of $53.44. And both investment will give me the same future value at the end of 70 months. Okay, so please keep that in mind. Part I. Oscar plans to invest $200 each month for 74 months. So this is N. So let me just write this down. Okay, N is equal to 74. And his investment will earn interest at the rate of 0.008 per month. So in another word, this is the interest rate. So let me just write this down. So R is equal to 0.008. And then this means that is in this column here. And then N is 74. So that means we go 74, we go across. So this is the present value. So this means that Oscar make a regular payment of $1 for next 74 months. So the present value for this is $55.68446. But then his regular payment is not $1, it's $200. So therefore, we know that from 1 to 200 is 200 times. So we times this by 200. So therefore, on the right hand side, we have to do exactly the same. We times by 200. So therefore, I just put that on a calculator. 0.89. So therefore, the present value is $136.89. So there you go. Part 2. Lucy is using the same table to calculate the loan repayment for her car loan. Her car loan is $21,500 and will be repaid in equal monthly repayments over 6 years. So we know that is monthly repayment. So let me just write part 2. So the monthly repayment is 12 months in a year. So we know that 1 year, Lucy will pay 12 times. So she paid for the next 6 years. So N is 12 times 6. So that will give me 72. And the interest rate is 10.8% per annum. But because she made monthly repayment, so therefore the interest rate must divide into 12 because 12 months in a year. So R equal 10.8 per year. But then because we need to convert to per month, so we divide it by 12. So that will give me, so I just go 10.8 divided by 12. So that is 0.9%. So 0.9%. So this means that if I convert to decimal, so I just divide by 100 because 0.9% means 0.9 over 100. So if I divide by 100, so I just go divide by 100, that should give me 0.009. So equal to 0.009. So now I can just look up the present value table. So 0.009, it is column here. And then N is 72. So 72 is here. So the future value is 52.82118. Okay. So that's a future value. So let me just write this down. So if Lucy make a regular contributions of $1, so the present value is 52.82118. But then the present value is 21,000 because that's how much she borrowed. So that's a present value. So 21,500. So that is the present value. So from here to here, we need to work out how many times. So just use calculator. So I just go 21,500 divided by 52.82118. So that is 407.033 and so on. But because with money, we just round up to 2 decimal places. Okay. So 407.03 for now. So we times by 407.03. So whatever we do on the right hand side, we do exactly the same on the left hand side. Okay. So therefore, so from here to here, we also times by 407.03. So that it give me 407.03. So therefore, the regular payment is $407.03. So in another word, the monthly repayment is $407.03. So therefore, so there you go. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? So let me go through it with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into this. So first of all, we know that Martina is borrowed $500,000. So this means that is the present value. So the present value is $500,000. And the interest rate is 1.5% per annum. But then we compound it monthly. So therefore, we need to convert the interest rate into month as well. So therefore, R is equal to 1.5% per year. We need to convert to per month because we know that 12 months in a year. So we divide this by 12. So I just go 1.5 divided by 12. So that is equal to 0.125%. But then I want to convert to decimal, so I divide by 100. So if I divide by 100, so this is exactly the same as 0.00125. So 0.00125. Okay, that is the interest rate. And we know that she need to repay over 30 years. So therefore, N is equal to, so 1 year, she had to pay 12 times because she had to pay monthly. And then 30 years, so that means we times by 30. So 3 times 12 is 36, so 360. Otherwise, you can just put that on a calculator. Now we can just look up the table. So we know that for N equal 0.0025, so that means in this column here. And then we have N is equal to 360. So 360 is this column here. So therefore, this is the amount. So that is the present value. So let me just write this down. So if Martina make a regular payment of $1, so this means that the present value will be 289.75411. So that is the present value for $1. But then her present value is this, $500,000. So therefore, we need to work out from here to here how many times. So I just put that on a calculator. 500,000 divided by 289.75411. So there you go. Let me just write this down. So we times by 1725.601 and so on. So therefore, on this side, we do exactly the same. So we times by 1725.601 and so on. Okay, so they give me the same amount. So that is 1725.60. That will do. And because with money, we just round up to 2 decimal places. So therefore, that is her regular payment. So her regular payment is $1,725.60. Monthly is $1,725.60. So there you go. I hope you got it correct. And thank you so much for watching. Bye.